Welcome to another episode of the podcast. The topic today is troubleshooting and repair of PV systems. We are going to discuss troubleshooting procedures, typical faults, and how to repair off-grid PV systems. And troubleshooting, I find personally, is one of the most difficult parts of PV system installation because you really have to understand all the processes to be able to understand how the PV system works and what is wrong with it. So it's kind of the next level of installation. So yeah, it's kind of advanced skills required for that. As an expert today, I invited a person that is quite experienced with solar PV systems and has fixed already many of them. His name is Steve Harris. He is based in Zimbabwe, the co-owner of JVS Projects, a Zimbabwean company, and he knows a lot about electrical installations and all kinds of solar installations. Do you want to introduce yourself with a few words, Steve?
Thank you, Vivian. It's a pleasure to be here today, and I just hope that I live up to that wonderful introduction. I qualified as an engineer the difficult way. I went into our Air Force here many years ago and learned all my basic skills on the tools, hands-on, and then when I had finished my apprenticeship, I wrote my engineer's license, and then came through the long way, if you like, not going through the university side, but eventually we got there. And for the last 40 years, I've been very interested in fixing things and simplifying things, because far too often I believe we make things much more complicated than they need to be, especially in the realms of machinery and electrically. So many things are done that complicate matters, which leads to problems down the line, because we haven't sat back and thought of the design of whatever it is. We haven't taken that 5 minutes at the beginning of the process to get to what is it that we're trying to achieve, and then work back and say, how do we achieve this most efficiently with best engineering practice? And I've found that time and time again in all of these installations we've looked at. And 90% of the problems I've found, and I've spent over 40 years now troubleshooting, 90% of it is because the original concept was flawed through lazy thinking. So we at JVS Projects, a group of us started this company 15 years ago. We started off as project managers, trying to implement what we believed in. And along the way, we picked up a couple of manufacturing companies. We picked up an automation company, and we've become partners with some of the biggest names in the industry, like Siemens and Schneider. And for the last 6 years, we've been active in the PV side of things, the green energy, if you like. All my life I've been involved in alternative energy in terms of diesel systems or battery backup systems or that sort of thing. But given the issues in Zimbabwe and in the region actually with non-availability of grid supply, we've gone more and more into standby systems, hybrid systems, and pure off-grid systems that we have looked at developing to best meet the customer's needs.
Okay, feels like I invited the right interview partner for this topic. Tell me a bit more about what you've been doing in the solar sector. What kind of PV systems is JVS installing? Are you installing at all, or do you only do troubleshooting?
No, we install a lot. We design and we install. As you know, I went through the Green Solar Academy training route and been through that, and I'm now a trainer as well, which is very gratifying because I love to pass my knowledge on. I love to pass my experience on. And we find that we are contacted frequently to help design systems. We are an EPC ourselves. That's from the engineering into the installation, into the commissioning. We do that on a regular basis, but we have decided to cherry pick our clients, and we look now at the smaller NGOs, if you like, or the voluntary organizations, not NGOs, the PVOs, the people who are running orphanages and clinics and things like that, predominantly out in the rural areas, and that is where we focus on for our bigger projects. There are many, many people out there who can do domestic installations and stuff like that, and we assist people in their design, but we try not to get involved in that as JVS Projects. I mentioned earlier we have a manufacturing aspect to it, and we do, outside of the PV side, we manufacture a lot of electrical equipment, big switchboards, motor control centers, and so on. And we manufacture a range of solar-related products like combiner boxes, battery stands, inverter mounting panels, roof mounting systems for PV panels, freestanding array systems, and so on. So we try and take a holistic point of view from it. And of course, what happens is some of the things that you've installed require maintenance. So every installation we go to, that we do, we try and empower those local people to understand how a PV system works and what they need to maintain it in terms of cleanliness, tightness of connections, and we try to give them the fundamentals of how sunlight becomes power that turns on a light. And we find that if we give people basic information and empower them to think for themselves, we don't really have a problem.
That was confirmed in actually a couple of other podcasts that I recorded already, where literally every installer said that the more you educate the client and the more you involve the client in the process of maintaining the solar system, the more successful it gets.
Yes, and we find in the rural communities especially, we've done a couple of rural clinics where we actively engage that community in the installation process. And those guys took it on board. It wasn't something that someone else had paid for, and then if it broke, they could just phone this person 7 hours away. They actually have taken it on themselves to be a part of the process. And we did 2 of those 4 years ago now, and we have had almost no problems. Those systems are still working 100% 4 years later.
That's amazing. I think unfortunately that's not the normal situation. Let's start looking at troubleshooting. So what is troubleshooting anyway? What does it entail?
I suppose the best way to think about it is when the customer's expectations have not been met. And this can come from a number of factors. But when they're not met, the system fails. It either switches off, which is the most common way of doing things. There isn't a fault so much with the equipment, it's everything has turned off. Because the equipment is pretty sophisticated and has a lot of self-protection built in. So if we look at that, the most common problem is the customer has either overloaded it or has used it when the batteries are very low because they haven't got an understanding of how much load you're taking off it while there's a cloudy day, for instance, or something like that. And you will find predominantly with us, it's an AC system. We've got inverters. We have very few pure DC systems out there, just the nature of our market. And so we have a lot of inverters that switch off. And again, it's education of the customer to get them to understand what the limitations are. And if you exceed the limitations, a little bit of training on how to restore that. And we'll just gloss over it, but it's quite important for people to understand that when they've got electricity in their house, whether it's purely off-grid or a hybrid, they get used to it. And so I've had 30 or 40 days of sunlight, and I do this and that and the other, and I get used to it, and I forget that I have a limited tank called a battery. I just seem to have had this seamless flow of electricity. Then we get a week of rainy, cloudy weather, and I don't have this seamless flow of electricity. It's a problem, but it's not a fault. It's just a consequence of expectations. And we try and give that to the client because they go, oh, my system's broken. No, it's not broken. It's actually working properly within its limitations. But a lot of people think of that as a fault. So let's just clarify that, put that on the table now, is a lot of what people think is a fault isn't. It's just the parameters of the system have been exceeded, and it's a really good opportunity to upscale or upgrade or whatever you want to do to it, because the people now have seen and tried and seen what works. But when we do get faults, they do exist, and so often they are caused by inappropriate equipment, inappropriate materials, or shoddy workmanship. And a lot of those come about from people trying to cut corners, either on the design or on the installation. We see it all the time. I've got a whole rack of beautiful cable connections in my storeroom here, where we find people that go out on site and they cut the connectors off the back of the panels and then connect the panels together by twisting wires and a little bit of insulation tape, and they will mix the proper PV cable with a hard copper cable, which they now run into the inverter or off to the batteries, and it's just a nightmare waiting to happen. Corrosion, hotspots, fires. I've seen it, where people literally just make their own connections. To those listening to this, an MC4 connector doesn't cost a lot of money. Use the right connections. You'll save yourself a whole world of pain, especially if you've got your panels mounted up on a hot roof. Once you've got a bad connection inside a PV array, inside a PV string, and it's underneath the panels and between the panels and the roof, you're going to struggle to find that. You really are. So do it right the first time. Spend a little bit more money and do it correctly. One of the second things that we see is people don't even think properly about volt drop in the cables. And so they will go, oh, well, I can put 4mm cable from the string to the charge controller. But no, do the sums. They're there, work on the sums. If you need 6mm cable, then put it in there, because you will melt that cable. You will create a hotspot at your string fuse. You will have an issue and you will have a fire. I have seen 3 or 4 of these now where the cables have been underrated, and at a bend or at a tight point or something, that heat builds up and builds up and builds up, and suddenly you've got a fire. And you can't stop it, because one of the things that we must understand about a PV generator is while the sun is shining, the generator is running, and you can't switch it off unless you get on the roof and start either disconnecting the things or putting blankets or cardboard or something over the top of the panels. And when you've got 18 or 20 panels on a roof, it's quite hard to switch it all off. Use the right cable. The next area of faults are the actual connections into the fuses on PV strings. They will work loose over time, because the cable, you have this expansion and contraction as the cables warm up and come down. It's a common thing. Once a year maybe, check and tighten everything if you can. And I know sometimes it's difficult if it's a long way away, but if you can, make a visit back to site a month later. Go and check the tightness of all the connections, because guaranteed you can have made them as tight as you want on the installation, they will work themselves loose. And you don't need it to be very loose before it becomes a hotspot. Moving on from that, the whole sequence of connecting and starting your inverter, connecting it into the batteries, the charge controllers, all the rest of it is laid out usually in the manuals of the inverter and the equipment. And I mentioned this thing about taking 5 minutes or so on to think about a design earlier on. The number of people, and I don't know what it is. It might be a guy thing. I've never understood it, because I'm a guy and I read the manual. Read the manual, because it's simple. Those manuals were written for a reason. Read the manual, guys. You'll save yourself a world of pain. Just read it, and it'll give you the sequence on how to switch on. I'm on a number of WhatsApp chats and forums, and we even had one yesterday going on about a person with problems with the batteries, the PylonTech lithium-ion batteries. If you read the manual, you would have seen everything you needed to know, instead of waving a flag on a WhatsApp chat saying, what do I need to do? No, just read the book. So all of you listening, read the book. Just sit down with a little drink of coffee or something like that, water or a Coke or something, read the manual for 10 minutes and a lot of your problems won't even appear. You'll learn what charge ratings you need to have, what settings on dip switches, what sequence to connect it onto and switch the inverter on. It's simple. It sounds simple to me, but some people just go, oh no, I think I must just connect these wires.
And also the manufacturers, they put lots of effort into making our lives easier by writing those manuals. And all the product managers I know from manufacturers, they are really like, oh yeah, I put this in the manual. They really take care of what it says there and try to make it easy for us. So it really only takes taking the manual and reading it. But let me summarize. So you already listed quite a lot of possible failures, like typical problems you get when you're out to troubleshoot the system. So we have the customer that is using the system wrong, or not wrong, but too much maybe for the situation. We have wrong installation and wrong selection of components, like wrong for that purpose. We have insufficient design, voltage drops that you mentioned that were not considered in the cable sizing. Too small PV generators would count for that as well. Just, not taking everything into account in the design process. We then have maintenance and connections, not enough maintenance on the system, loose connections, dirty panels, something like that. And last one, wrong preparation and wrong handling of components when commissioning them. So what would you do if the system is not working? I mean, that's a clear case. Then there's no power coming, the loads don't work, so it's clear that something is wrong. I think a bit more difficult is to notice that the system is not operating as it's supposed to be, like that there's not as much power production as you predicted at the beginning or something like that. How do you notice such an error?
That's a really hard one to answer because of the variables that we have with sunshine, with cloud cover, with dust cover, pollution cover, if you like, and load. So how we would start that off is if we went somewhere and somebody's saying my system isn't performing as it should be, you go along and the first thing we would want to look at is how many panels are on there. We would do a very basic overview of the installed system from a design point of view and say, well, I see what you've got up here. I can see what you have in terms of cabling, what your charge controller is capable of, and so on, and spend 20, 30 minutes looking at all of those parameters and trying to deduce from that what I would think the system's capable of. And then it has been my experience that people generally have been oversold on what their systems can do. So they say, it can do this, it can do that, it can do the other thing. And when you look at what has been installed, it's not capable of doing it. Probably capable of doing something in absolute optimum conditions. But for me, mostly when it's a case of a system underperforming, it's because it's been under-equipped. So either the batteries are too small or there's not enough PV generation going on. It could just be dirty. That's a fairly common one. And people go, but it rained a month ago. And you try and say to them, well, that's one of the worst things that's happened because they've got wet and then there's been dust. So that black film you see or that brown film on top of your panels is actually not helping you. And that's a big one, is people not keeping their panels nicely clean, especially where we're located in between the tropics. We don't have very high inclinations or incidences of elevation for our panels. And we can run our panels almost flat and still get very good generation. But if you're going to do that, you must make sure you clean them because the dust layers can get on there very quickly. Another area that we find limits production is the inverters are running very hot because people stick them in these unventilated spaces for aesthetic reasons. Airflow is critical. If you have any electronic machine, if you overheat it, it's not going to perform to its best capacity. So we go and look at what has been installed and try and take the design back to first principles and say, you think you've got a 5 kilowatt or an 8 kilowatt installation, at best you should get about 3.5 or 4 kilowatts out of that.
So you should, like when you go on site for the troubleshooting, you should have like a few basic figures in mind that you can quickly calculate the approximate output of the system. And so you recommend that you should look around and take everything into account, in everything in the environment.
One of the most common things I've found lately as well is people seem to be absolutely focused on these high output panels, these 400 watt 72 cell panels, and then they'll spend a chunk of money getting a bunch of panels, and then they will put in a very cheap PWM charge controller, and they don't understand that is going to limit dramatically the output of the panel because you're pulling it to the system voltage. Nothing's moving. It's saying, well, I've got a 24 volt or a 48 volt battery here. You can have as much as you want coming in off the panels, but it's going to limit it to that voltage. So the power is there. The current is only going to be what the panels can produce. You're never going to get huge amounts coming off. So I think it's very strange why people would put expensive panels on a roof and then put a cheap charge controller. For me, it must be the other way around. Get the best charge controller you can get, and that will maximize the use of whatever panels you put up there.
Or at least match everything together. Like if you get high quality panels, then match it with the best battery you can find and the best charge controller. But tell me, how does a normal troubleshooting work? Like imagine you've been called out to a 5 kilowatt off-grid system. The customer said it is not performing as expected. How do you go about it? How do you prepare? What is the first thing you do on site? What is your troubleshooting procedure?
So we would go on site, have a look at where it is, and the first thing I would do is switch everything off. If we are talking lead acid batteries, which I don't like, we will disconnect those. We'll switch the inverters off. We'll open all of the fuses to the batteries, fuses to the strings, any power supply that's coming onto the inverter, whether it's from the mains utility, we'll switch that off. Let everything sit for a couple of minutes. And then we will do things like I'll measure the voltage coming in from the PV array. So we'll check and see if that's systematic. If there's more than one string, we'll check that the strings are all matching each other. If it's an east-west scenario, we should expect a difference. Let's see what the difference looks like. We'll have a look at the fundamental integrity of the installation. We'll test that every cable is tight. We'll check that there's no sign of overheating. We'll see that the fuses are correct. If we see any anomalies, like the voltage on the system isn't what we expect, we would dig deeper into what's going on the panels. And that's where we've discovered some of these absolutely horrific jointing systems, where people have just literally, they've just twisted the wires together. They're not soldered. There's no mechanical connection other than a manual twisting. That's going to lead to trouble. What we have found on occasion is where people have just put the connections down on a roof space or whatever, water has got in, and so you have a problem with cutting off of a panel or something like that. Your voltage isn't what it should be. So that's our first step, is the mechanical integrity of the system, and we can check that on the PV side by looking at the voltage that's coming off it, and if it's where we expect it to be, that then takes us on to the next side. So we would then come in, start connecting things back together, mostly with the inverters, and there are exceptions, but I'll use this as our standard thing. We would be to connect the batteries onto the inverter. And without anything else on, we'll have a look and see what the inverter says. Is it telling us that the battery is low? Is it telling us that there's an issue? If that's the case, we'll have a look at, is there a problem maybe with the cell of a battery? It's quite difficult when it's a maintenance-free battery to look at stuff like that. And it's difficult to check a battery when you just go in unless you have a means of loading it up. So having a battery tester, which many people don't, and to be honest, I don't have a battery tester. If I've got any suspicions of a lead acid battery, I take it out and I bring it back to wherever it needs to be. I don't like lead acid batteries. It's just a personal preference with lithium ion around these days. So we will check that out. Is there a problem with the batteries? Is there a huge voltage issue with them? And things like the battery monitors, Victron battery monitors and so on, will give you a very good idea if you interrogate those. But they're an expensive accessory to add. I sound like I'm rambling a bit. I'm just thinking of all the different jobs I've done in the past and the way that we found the faults and the issues. And one of them was a huge lead acid battery bank where the batteries had cycled so many times that they only had like 15 minutes of life left in them. But they looked great, and the customer was insistent that his battery bank was fine. But they'd done something like 3,500 cycles, and he didn't want to spend the money for a new set of batteries. Anyway, the reality is that if your batteries are old, if they're cycling every day, you're only going to get about 3 years of life out of a battery set of lead acid batteries. And one of the things to remember is that a lead acid battery doesn't count a cycle in its internal chemical memory, doesn't count a cycle as a full charge and a full discharge. Any time that it starts to discharge and then recharges, even if it's only gone down 5 or 8%, that's a cycle in its chemical life. So having these lead acid batteries sitting doing little fluctuations doesn't do them any good. They need to work. Chemically they need to work. Otherwise we get problems on the plates. We get shortage of life, and that's where we find a lot of problems with lead acid batteries is people go, but I spent all of this money only 2 or 3 years ago. They're finished already. But they've hardly worked. Yes, they've worked a lot. It's like turning a car on and leaving it idling in the garage all the time. You'll do far more damage than taking it out on the highway and thrashing it, which is what the car wants to do. You just leave it sitting in the garage, it overheats, it's not good for it. So now we would look at that. Let's assume that the batteries are fine. We've got a bit of life in them. The inverter says it's good. So we switch on the inverter and we close the PV side. Once we close the PV side, we can see what the charge controller is doing, whether it's integral in the inverter or if it's a separate one. We have our DC tong testers, clamp meters. Have a look and see what's coming off the roof or what's coming off out of the array. Is the current that's coming into the charge controller from the panels what you should be expecting? If there's not, it's an indication that there's a problem on the array. If it is, then check the current that's going from the charge controller into the batteries. Is that what we expect? If not, the problem's possibly in the charge controller. It could be diminishing as well. It might not be the charge controller. It might be that the batteries are nearly fully charged. So we'll see that. Just keep watching it. If the charge current is slowly reducing, check the voltage that's coming off the batteries, and you'll be able to assess what the batteries are doing. If you've got a battery voltage monitor, that also helps. So our next thing to do is to look at what is the inverter doing. Is the inverter working? Is it tripping out? If you put a load on the inverter, what happens? And often inverters are overlooked because people think, oh, it's bolted to the wall, it should last forever. Anywhere that there's a dusty condition, which is pretty much all of Africa, those inverters, when they're working hard, working during the day, the fans in the inverter are sucking air through at a fairly significant rate. If you've choked the inverter, it's going to overheat components, which will slowly become more inefficient, and prior to failing, they may just become poor. They just don't want to work so well. But also, as they heat up, you'll have internal resistances, you'll have premature switching off, especially with electronic components like MOSFETs and so on, that they can switch, and they can switch erratically. So today might be 2 degrees hotter than yesterday, so it triggers today, or yesterday was 2 degrees hotter when they first noticed the fault. So what we've done a number of times where we've had reported faults, we've brought the inverters back to town, we've opened them up in the clean environments of our service centers, and discovered on a couple of them that they are absolutely caked solid with dust because the rooms have not been cleaned, the environments have not been cleaned. There's just a lot of dust, and the inverters cannot cool down. So they run into overheat and they switch off. So for us in Africa, that's a really big problem, is overheating of the electronic components in the inverter. So if you've got to a stage now where your inverter is running and it all seems well and everything's switched on, you've now got to say to the client, or you've got to do it yourself and say, what sort of loads does this inverter take? Do you put kettles on it or anything, and try and abuse it to reproduce a fault, and put a load on, put all the lights on, put the pumps on that you're using, the booster pump or the borehole pump or the sterilizer in the case of the clinics, and try and reproduce it.
So you're basically just asking your client, okay, when did it appear first? And then you try to make everything as it was in that situation so that you try to make it trip again or fail again.
That is a great way to try and visualize what's happening. And a lot of the inverters, you can set it up to interrogate the fault mode. So it'll record a certain number of faults on its own PC. So you can come along, plug in a computer and download the fault system. But you've got to have set that setting and most people don't set it. So you come along and they say, my inverter's not going. You change it and then come back. And what we have found is with a lot of electronic-based inverters, they're cheaper in the market, they're not transformer-based inverters. When you have repeated faults, it seems to cause a problem with the components and eventually they will fail. So if you've had repeated low voltages switching off the inverter because you've taken your battery to the limit every time and you're relying on the inverter to switch off on low battery, it's almost like the systems develop a fault because you've taken them onto their own limits, and then they just say, we can't take it anymore. Another common thing is that people push the boundaries where there's an integrated MPPT charger in the inverters, and it's another big failure, especially for MPPT charge controllers, is people put over voltage on the charge controller and it fails. And so they go, oh, my batteries aren't charging. Well, your charge controller has failed because you've put too many volts on it. You've put too many panels in there because you're working right on the edge of the parameters of the charge controller. And what we find, or what I found in our part of the world, is when we look at standard test conditions, we're talking of 1,000 watts of irradiance. That's our standard test condition. So when we do that, that's a 260 watt panel or a 305 watt panel. But our insulation levels in Africa are often significantly more than that. So get yourself an insulation tester. They're not very expensive, and you can actually see the levels of insulation. And what that does is it drives the voltage of your panel up beyond STC. So I know that there are issues with when it's cold, your voltage rises, but also when your insulation is going up, your voltage rises. And if you're pushing the parameters and you live in a very, very bright area, those voltages are going over the top, and eventually your charge controller says, sorry, I'm out of here.
And when it was designed on the edge at the beginning, then you will notice quickly, huh?
Yeah, and that's all part of the poor design that comes into play, or cost cutting in design.
Wow, yeah, quite a complex process to find errors and to identify errors. But I think the way how you described it, that you like switch everything off, kind of reset the system, and then start checking major points. Start checking, is it the panels? Yes or no? If yes, look for details on the panels. Is it the battery? If yes, then you can look deeper into that. I think then that is like how you save time on site. You check the major points and then you narrow it down to, okay, battery is fine, panels are fine, so it must be the inverter or the charge controller. So then you can get deeper into fault finding on that side.
Yes, and of course what I didn't talk about earlier on was things as basic as checking your fuse. So when you close the PV fuses again, make sure you've got voltage on the feed side of the fuse and not on the supply side of the fuse. You know, for me, that's just inside there, but it's a basic point to go. Check your fuse, do a continuity test, and check your cable. Don't assume that your cables, where you can test them, have got continuity. There might be a break in the cable because it was damaged or it was kinked. Maybe in a workshop, something fell against the cable and damaged it, and now it's a weak point, it's a hot point. If it's in trunking, it could be burnt. 2 weeks ago, I went and sorted out a system where the installer had used the incorrect lug. The corrosion level between the lug and the cable had actually broken the joint at the lug. When I went and changed the cable over, it wasn't a loose connection, nothing wrong with the switch. There was just corrosion between the cable and the lug, and the cable had broken. It had corroded away to nothing. That was a bizarre circumstance. Really bizarre. Just somebody took a cheap lug from inside his toolbox, and instead of using either the right crimping tool or the right lug for the cable, put it on, and he thought, oh no, that'll be okay.
I find it always fascinating that you fail on such a little thing and then it has an impact on the whole system, and it's like everything plays together, and then just a minor error will cause the whole system to not work properly anymore. But tell me, as a beginner, when you don't have 40 years of experience checking electrical installations, how do you go about that? I mean, when I go on site, checking the panels, okay, that's logical. Checking the batteries, yes, okay. What would you recommend? What can help me when I go on site now as a beginner? Is there a checklist I can work along, or what do I do?
Vivian, there are many checklists available. And really, it's just a systematic, logical process yourself. Look at the system and think to yourself, where could it go wrong? Where could somebody have taken a shortcut? What can I measure? If you're into this sort of business anyway, you're going to have a tendency to think in a logical, systematic manner, because I speak for myself, I'm not the sort of person who can write music. I'm not the sort of person who can paint these magnificent masterpieces, but I think logically and in a fashion of cause and effect. So where is the problem? And an understanding of the basics of electricity, an understanding of how does PV actually work, and then you sit down and just think it through. And I would say the biggest thing is don't rush it. There is nothing here that is hidden. It's either going to work or not work. So don't try and undo a charge controller to try and find a broken transistor or PC board or something, because you're not going to find that and fix the fault on site like that. If the inverter isn't working, isn't switching on, and the battery voltage is fine, there's a problem with the inverter. It may be just a little reset button underneath. So read the manual for the inverter. You may be able to reset it and get going. It really is as simple as that. If you're dealing with lithium-ion batteries, read the little handbook. There's a little reset. Lithium-ion batteries will switch off very often because they've been incorrectly sized for the system and the loads that come off the system, and then they will just switch off. Pylon Tech are a very common, very popular brand of battery. They have very stringent discharge parameters. So if there are not enough batteries in the bank for the inverter, It's very, very easy to switch off pylon batteries and think your system's gone down, and all it needs to do is reset the batteries. And we've seen that many times. So understand what components you've got. When you get on site, don't try and look clever and fix it in 5 minutes. Have a look at the equipment available that's there. Look at the manuals, and then look in the troubleshooting sections of the manuals as well. That's how I fixed a number of problems, is going in and saying, oh, this is what the problem appears to be. What is that? Oh, look, in the manual it says, here's a comms problem. And why is there a comms problem? Oh, I've got this in the wrong place, or something is incorrectly connected. And you put it back and suddenly you've got, and that was the problem we were talking about earlier on, about this whole thing that came up on a chat group yesterday, was because the installer had done what they thought was right with the dip switches on the battery. Instead of reading what the manual of the battery says, they just went, oh, well, I should do this. No, different inverter, different battery. Do what the manual says.
So I'm taking from that beginners, when they install their first systems, select components that are like useful for many kinds of applications, stick to them, really work deeply into the manual, understand all about it, so that when it comes to troubleshooting, you don't have to read 10 different manuals for the 10 systems you installed, but you have like always used Pylon Tech batteries, always used, I don't know, Schneider inverters, so that you can be faster in the troubleshooting and the repairing procedure.
I think you're right there, Vivian. None of us can be experts on everything. I personally have nothing against Victron products. I think they're fantastic. I know nothing about them. So when somebody phones me and says, I have a problem with my Victron, this and that, I say, I know a really good guy to call.
So is it more difficult to fix systems that you haven't installed yourself?
I think so, yes. You've got to spend a bit more time looking into what's in there and trying to understand how that person who designed it and installed it did it. And I've looked at many, and I'm really scared when I see the number of shortcuts that are out there and how dangerous they can be. And so many shortcuts are out there by people they are either ignorant of the dangers, or they're trying to maximize their return, but they're not doing their customers any favors.
Talking about shortcuts, or maybe saving money rather, and optimizing for your own business, what can you do before you drive out to site? Because I mean, you drive out there, and sometimes when it's off-grid systems, it's quite a long drive. What are the things that you should ask or organize before you drive out?
I think we tend to try and go through as much of the basics, the restart, the fundamentals, like, are all the switches on? How did you try and restart the inverter? Have you cleaned your panels? If the people are able to do a small voltage check or some fundamentals like that, we ask them to do that. And often we will use WhatsApp or other media to get photographs of everything that's there. Getting small videos is really helpful. And if we can do a live chat with somebody on a camera, we will try and do that. And in our part of the world, the coverage is generally pretty good in most areas. Because of the cost of data, though, we don't have, when I say we, I'm talking about, in my experience in the systems I tend to look after, we don't have much remote monitoring. So I would dearly love to say, oh, well, I can just jump on my phone or my laptop and have a look at what their system's doing or has done, but we just don't have that. I know a lot of people that do, especially if they're in a more urban environment. That's how they do their troubleshooting. And it's a great way of doing it. For my clientele, that really isn't the way forward. So we just try and engage with them, see what they try and do. We hold their hands through the basic processes. In some instances, we've left tools with the guys. We've showed them before we left. If we have to do a restart, it's going to be like this. You're going to need to do this and that and the other. So we leave them with a checklist of what to do.
How much do you charge for troubleshooting? How does it work? Like, do you charge for going there? Do you have contracts? Who pays for the replacements?
somebody calls us out of the blue and says, my system isn't working, if it's not one of ours, we say, okay, if you want us to go there, how far away is it? It's going to cost you X amount of money upfront. We factor in a bit of time for a visit, and we'll say that's what it's going to cost. And that's going to get you an opinion and an assessment, which is going to be in writing. If there is now work that needs to be done to put it to rights, and often that will include things like upgrading an inverter, maybe we're putting in more batteries or whatever, we would then, in the final tally of everything, credit that assessment and troubleshooting. We would discount it off the final bill because it's an investigative visit. But if somebody wants the benefit of our experience and knowledge, and then they're going to go and look for some other guy to fix it for them based on our recommendations, then we've received payment and we say, off you go and good on you. For a lot of our customers, being as they are in a PVO type environment, we do all of those visits on the house. We'll have a look at it, especially if it's our own systems. We go out there as part of the after sales service. We only charge when it's not our system. So in anything where there's a fault or a problem after the event, we go and look at. If there is a problem, and we've had two now where there has been very obvious customer interference, or an employee of the customer has fiddled or done something, there is a charge for the repair. If it's equipment that's failed and it's in the warranty period, of course it's free of charge. That's basically how we try and work.
Okay. I have a million more questions, and I think we could go on for at least another hour. Let me ask one last question. What do you do when you can't find the fault? When you checked it all, you just don't find it.
I'd love to say that's never happened to me, but we have had at least one instance where the customer's system hasn't worked. It works fine and then doesn't. It works fine and then doesn't. What did we do? We replaced all the equipment. Still don't know what was not working. We just changed the make of the inverter. We redid everything. So it was quite extreme, but a good customer. He had paid a good amount of money, and fortunately he was very close by, this customer. So it wasn't like we were traveling. I don't know what it was, whether it was an issue with whatever loads, but we changed the make of inverter from one that we thought was going to work for him, and we changed it completely to a different style of inverter, and the problem went away. And let me just say that the first type were electronic-based inverters, and then we went to transformer-based inverters and didn't look back. So whether there was a harmonic on his load that and a lot of what he did was variable speed drives and things like that. So whether his load affected the inverters, I don't know. But changing the inverter, we haven't had a problem since. But we literally had about 10 days of trouble-free working with the first ones, and then just repeated errors. We swapped out the inverter for a new inverter that was of the same brand. 7 days later, repeated error. Changed the brand of inverter, and it's gone away. I mean, sometimes you've got to do stuff that costs you, but your name is more important than trying to cut corners. That's what we work on anyway.
Yeah, definitely. I think that's a good advice. Sometimes you have to do that. It's good to hear that nothing goes perfect and that everyone makes mistakes. Quite encouraging, actually, for everyone who starts. I think we could clear the most urgent questions, even though this topic is probably my most favorite one, because it brings everything together, really. All the experience, all the logic and understanding of PV systems combined. That's really the most challenging and most interesting part, I would say. Thank you for sharing all of your experience, Steve, and for taking us with you on your troubleshooting journey all across Zimbabwe.
It's a pleasure, Vivian. Let's do it again.